Dr. Mark Manary on the role of optimized plant protein in the treatment of acute malnutrition. Professor Mark Manary has been working primarily in Malawi. He's been a senior lecturer in the University of Malawi since 1994. He did his undergraduate degree from Massachusetts Institute of Technology and his medical degree from Washington University in 1982. He is the director of Global Harvest Alliance, a joint venture of St. Louis Children's Hospital, Washington University, and Donald Danforth Plant Science Center that's focused on developing native foods to combat malnutrition in the world's poorest country. Currently, they're working on a nutrient-fortified, genetically engineered cassava plant. He has developed a ready-to-use peanut butter-based therapeutic food that is saving millions of children's lives in Africa and beyond, and now is the WHO gold standard for the treatment of malnutrition. He is one of the foremost experts in childhood malnutrition, and though he's been working mostly in Malawi, he works right through sub-Saharan Africa. His early professional experience in missionary medicine in Tanzania and at an Indian reservation in South Dakota set the course for his career. Over to you, Dr. Malary.
Thank you, and thank you for inviting me to speak today. The topic I was given, as kind of an orientation there, we got a long introduction, but I'm a pediatrician by training, a chemical engineer by training, a person who's highly driven to help underserved populations and have been working in sub-Saharan Africa, living in sub-Saharan Africa since 1985. So my affiliations with institutions in the US are really that they sponsor me in my work there in Africa. And I was asked to talk about plant and proteins in their role in treating acute malnutrition. So I think that when we say acute malnutrition, or when I say it anyway, what I'm talking about here are people that have had primarily a acute, being over several weeks or a couple of months, shortage or deprivation of all foods. Okay, so they're very thin, or they have edema, and these are people that are actually mostly children, and they're very sick medically as well. So it's a specialized population, and we can't really start thinking about what's good for these people might be good for healthy children in some other setting and whatnot. So let's move on here. So one of the main messages I want to give it in dealing with acute malnutrition, so children that are too thin, all of their organ systems are affected. So in other words, you may see the child with wasting muscles, but you have to appreciate that child's heart muscle is paper thin too. And their lung capacity is the extra capacity they have for providing oxygen to their body is also compromised. That the most important nutrient is protein. And protein is an old term, you know, we measure it in grams or something, and grams per kilo per day. But I mean, the reality about protein is it's just a class of these very important molecules, amino acids, and almost all of those amino acids are limited in some way. We talk about essential amino acids and 8 essential amino acids, but 17 of the 21 or so amino acids cannot be synthesized in adequate quantities. Some of them have to come from the diet. And so this is what these kids are missing in large part. And protein is not simply just being in the food, but it's being able to be, the proteins need to be broken down and digested out of the food matrix. And foods, of course, have other compounds than just macronutrients. So there's other kinds of bioactives that modify, in a sense, some of the effects of protein. This graph over here is looking at protein quality, which is a measure of the mixture of these amino acids, and growth or response rate. And what we're showing you is the slope, and then the very extreme slope there is that recovery from malnutrition is highly dependent on the amount of protein children get. And even though some people would say, oh, what's the requirement of protein? I mean, we're talking about numbers that are 5 and 8 times greater than that. So we should never be afraid of giving lots of protein in these kind of kids. This is plant sources of amino acids. It's meant to show you that these amino acids are in fairly small quantities in most plants compared to animal source foods. But the ones that have the most are the ones highlighted there, ones we've done preventive trials with, cowpea and common bean. Soy is almost a worldwide food. I can't think of a place where there's not soy in fairly widespread use. So plant versus animal sources of protein. So as I said, it's the amino acid composition of the proteins. We have to think about the food as a whole. So what kind of other kind of bioactives are there in the food? And for example, isoflavones are a class of polyphenols will oxidize 3 specific amino acids in particular. So they will cut down on the amount of available lysine and sulfur-containing amino acids that may be able to be measured in some kind of way in the foods. The best sources, plant sources of proteins, are legumes, beans. Comparing legumes to milk protein, it's partly an issue of how easy it is for the body to digest those proteins. I mean, people hear a lot about the wonderful protein in chickpea, which is 25% digestible, which means that you have to have 4 times as much of it to equal something in milk. And the cost is also important if you're thinking about this on a scale where families can't necessarily afford to get different things. Plant proteins are about 10 times less expensive than animal source proteins. So it doesn't really help just to say, oh, animal source proteins are so much better, who would choose otherwise? Well, if you've got a limited amount of money to spend, you might well choose otherwise. And as I said, it's absolutely key. The kind of recommendations that are out there in terms of like the WHO and so forth about protein are very archaic in my mind. I mean, these are people who look back and they say, well, a gram of tissue has this and that amount of protein in it, and that's really what we have to give. I mean, empiric data show that giving larger and larger amounts of protein usually result in better and better recovery and growth. And I, for one, am an empiricist. I don't believe we can understand all the biology is too complex for us in many ways. And so what I tend to do is if something works, I tend to want to do more of it. And if it doesn't work, then I tend to not want to do as much of it. So just a warning out there about following those recommendations. Because children, I say, we typically now give 4.5 grams per kilo. That's been shown in its trials superior to 3.7. WHO is going to tell you 1.6 grams of protein per kilo would be adequate for a severely malnourished child. Over there on the graph is some stable isotope data where we're just showing you in a fairly limited group of kids, 30 or 40 or so, that when you give them more protein and higher quality protein, the egg tryptophan was in a way chosen just to provide exactly what we thought those kids with a lot of inflammation would need. What you get is more protein synthesis, and you don't get the protein being wasted, which is some biochemical evidence to support this as well. So, there have been trials of treating these very sick children. So, okay, to back up one then. So the recommendations for foods, including for treating very acutely malnourished children, include that a sizable portion of all the protein come from milk or dairy. For severe kids, it's half, and for moderate kids, it's about a third. And But there have been folks that have done trials and investigations without this much dairy, and I wanted, or because of the title I was given, to go ahead and run through a couple of those quickly. So, for one, being a person who's trying to maximize the impact of what we're up to, in Malawi back in 2009, when ready-to-use therapeutic food was kind of the standards of it were set by a WHO expert committee in 2007, I said, wow, that's so much protein from milk, can't we do with a little less? And we did a trial where we substituted, it was 15% of the protein. It has to be 25 from milk, but we gave them 10 of milk and 15 of soy, and the recovery rate was less. They didn't all die or something terrible, but that wasn't optimal for the child. And then there have been 3 trials in the last couple of years which have focused on soy, maize, sorghum mixtures, and then one of them augmented those with crystalline amino acids that are made by bacteria and then added as almost a specific kind of supplement. And what we see there is there's not a comparison group on this slide, but these recovery rates, are 53% or 72%. I mean, we would be shooting for 88% or 90% typically with the standard food. So these are inferior. And some of these trials have researchers, we all really want to succeed. So sometimes we choose our populations to help us look as successful as possible. And that's been the case in the last trial for sure. Because most of these kids with acute malnutrition in Africa are under 2, by and really large. I'm talking about 90% of these kids. And this population happened to be half of them over 2. So we always have to be a little careful when we look at just these numbers. Is that population the same as the one that I'm really trying to treat? And I know that this might not play so well with the audience here, but in the U.S., if people that buy and sell property, houses and buildings, they say, location, location, location. It's the whole thing about it. It's not what the building is or how good it is. And it's the same thing in nutrition. It's context, context, context. Who are you talking about? Where do they live? What do they habitually are exposed to? That's really, really plays a huge role, rather than sort of more basic biological or scientific investigations where molecules are going to behave the same way in a variety of environments. So that's really important to consider. These crystalline amino acids I was asked to specifically comment on, and these are equivalence trials. Now, for those of you who know about these kinds of trials a bit, equivalence trials to me, a superiority trial uses some fairly standard, straightforward, easy statistics where you see what the chances of finding these 2 differences are. And if it's more than 95, it's less than 5% that those differences occurred, we're going to say that probably is representing some kind of biological phenomenon rather than luck. In equivalence trials, the investigators are allowed to choose a number that's equivalent, and then to see statistically if it crosses that number. So in these trials with the crystalline amino acids, these people chose 10% equivalence. So in other words, if you were getting 80% recovery, then 70% recovery would be considered not equivalent. But what's happening to that 20 or 30 other percent who aren't recovering is usually something very tragic. So I would argue that when you look at an equivalence trial, it's not quite like a superiority trial. You have to pay attention to this, what's been a priori chosen as the equivalent factor. There's some details about the crystalline amino acid trial, but my own take-home message for you about adding amino acids to the diet to achieve a very good protein quality is, at this point in time, we don't have enough evidence, and I think we need to be kind of buyer beware or suspicious about the role that these might play. One reason I would say that is that the people who feed animals for a living, farming livestock, who use all kinds of different additives to the food, are very suspicious about using so many of these amino acids, and they're concerned about damage of the gut. And also, the physiologic processes of these proteins provide small peptides. They don't just provide amino acids. They're not just simply building blocks. And what those effect of those proteins and the bioactives in the food as well will be missing. So I think this was the message I was trying to give you about these crystalline amino acids. We don't know the effect they might have on the microbiome or on cognition. And we know there are effects depending on what kind of foods we use to treat acute malnutrition on both of these, some on the good side, some on the deleterious side. So it's just too early to know whether our future is going to be processed food where the amino acids are titrated to exactly meet what you need. That might be for my granddaughters right now. So for the severe kids, I think that these kids are very fragile. Left untreated or poorly treated, 13% are going to die in the next month. And the most common reason they're going to die is because of sepsis. And where the sepsis comes from is translocation of gram-negatives from their gut, because as we know, malnutrition weakens and damages every organ in the body. So in those kind of cases, really, medical personnel prescribing, if you will, or administrating, if you will, even if the diets can be given at home, and they can, far and away, is the right thing to do. And not having a lot of leeway about what's in there and making decisions because something's cheaper or not. I mean, whenever the Lancet goes and looks at the cost effectiveness or the DALI save for really a severe acute malnutrition that's primarily the result of not having enough to eat, treatment at home with ready-to-use therapeutic food always wins, in a big way in terms of how cost-effective it is. But moderate acute malnutrition is something that I think that some people are rethinking a little bit. So it's children who are wasted, so children who have a weight for height that's less than a couple standard deviations, or an arm circumference that's more than 2 standard deviations or so less than the norm. And these children there's a lot of them, first of all. People often throw out the number of 50 million, but that's a prevalence number. And if you look at the incidence number over a year's time, you multiply that by 2.5. So we're talking about 125 million children in the world are going to experience a wasting during a given year. So these are big kind of population numbers. And so what can we do about these to help these particular children? Because they're sitting at a risk of death of about 4 times what the population that they would normally live in if they weren't wasted. So they're at increased risk of death. They're sitting with about 8 less IQ points, if you want to talk about it in cognition, than a well-nourished child in their same society. So these are children who deserve to get some help. I think in the U.S., what happens to these children is they work them up send them to our friend Pascal, and they look for chronic Crohn's disease or something else. But a lot of times they're also, throughout the world, just simply having a poor diet. So this is not a situation where they need to be given, or they can be given even, a highly prescribed or formulated diet, but you certainly want to encourage or provide, let's put it that way, giving these kids what they need. So in other words, the severe kids need everything. They need a lot of garden variety fat and energy in this. These kids need micronutrients and high quality protein is what MAM kids need. And so if you're giving them a supplement, that's what it should include. And that is actually the most expensive things to buy. So, there's a balance or if something's in contradiction there, the cost is going to be high for these kinds of supplements. And studies we've done with like I showed on that first swing with a graph showing growth rate versus protein quality, show this for MAM. A couple editorial comments about protein quality. It's something that it's not an intrinsic number for a given food. Okay, it's not something like if we want to measure how much vitamin A is in a food. Sure, there may be analytical problems, and there may be problems with sampling what's typically in a plant, but there's a certain amount of micrograms there. But here it's based on the child's need, which is the other half of that equation. So if you're underweight and you need to put on muscle mass and you need to build a stronger heart, you need more protein. And usually the numbers use a denominator that's, healthy children in North America, age 1 to 3 or something like that. Some fairly irrelevant sort of population. So when we've done all of our work, we've developed a protein quality scoring system for the populations that we're working with. And unfortunately, this is going to make several foods protein quality look worse. So if chickpea, for instance, is 25%, and the legumes are 48 and 53, and fairly low amounts of protein quality. So the ideal treatment for MAM is some kind of supplementary food with a high density of micronutrients and essential amino acids. In some contexts, it's appropriate to provide that to people. In other contexts, you encourage it. I think that my experience has been, it's usually not a case of ignorance, but it's more likely a case of a disrupted family situation or poverty that's leading to these malnutrition problems, these uncomplicated malnutrition problems. So lots of education, the evidence base for nutrition education being an effective intervention for acute malnutrition is 0. WHO came out with an interesting recommendation about a year and a half ago, and they said, well, in associational studies in Europe and North America, children that gain weight faster in infancy are more likely to be obese. And so therefore, with these acutely malnourished children, we're not so sure it's good for them to gain weight quickly. And this kind of flies in the face from the sort of frontline clinician like me, what we're seeing with these kids. I mean, they need to get help and get better fairly promptly. They don't need to be deprived in a controlled manner for longer periods of time. But this particular recommendation by WHO, context is what matters. I mean, maybe that association will end up looking like something like causation, which usually never is the case, but for well-nourished children to start with. But for acutely malnourished children, there's no reason to be cautious about trying to get a severe and moderately malnourished kids fed back to recovery fairly quickly. We am embarking right now on a a trial in Sierra Leone. So I think I alluded, I do my work in Africa, that's where I live. I have 4 countries, and each country has about 50 people or so employed as study teams. And what we bread and butter do is randomized clinical blinded trials, testing interventions or prevention interventions. And we're doing one now where we did our very best to get education and mother care groups and social support groups for children with moderate acute malnutrition, and it's not working well at all. I mean, when I was at that WHO meeting a year and a half ago, Nigel Rollins, the program officer, he said, "Mark, what do you think about these modern MAM kids? I mean, how many of them are just going to get better on their own?" And I said, "Well, we don't know, Nigel, but I'm going to guess half." Well, I was dead wrong. It's looking more like 10% here from our data. So that's just a vote is that wait and see on moderate acute malnutrition is probably not in the child's best interest. And studies that have looked at body mass composition of children is when they're eating whatever kind of food they're being fed, whether it has a lot of fat or it's all plant-based and has a lot of carbohydrate or whatever, it's mostly all being put on, over 90% on is lean body mass. So don't worry that the composition is somehow going to affect the future, because this is really a short intervention. I mean, MAM, we're talking about 40% of kids, if fed a high-powered supplement, are going to be done in 2 weeks, and 80% in 4 weeks. I mean, this is not, some courses of antibiotics last that long, kind of thing. So I think public health lens on MAM and SAM. I think I talked about this. The incidence is much higher than the prevalence. These children are almost all entirely in South Asia and Sub-Saharan Africa. And today I'm in South Asia and I'm talking to people who are far and away predominantly from South Asia. And what am I from? I'm from Africa, and context matters. So I'm telling the stories and the lessons and encouragements I'm sharing with you. Really, I'm very solid about them about Africa, but we see very different patterns. Those epidemiology sorts that we started the conference with in South Asia. In Sub-Saharan Africa, we see children maybe born a little bit short, occasionally underweight, do great with their breastfeeding the first 6 months, and then after that they start faltering. Whereas the data I've seen from South Asia and the colleagues and collaborations I've had with people, those kids start faltering early on, and so they may need a different type of approach. And to the last the thing on the far right over there is just to say that because these children may not be our children or the children living next door to us or the children that we take care of in practice, or they're still representing a very, very large number of children in the world, and they're not all in Africa. So my final words, and we probably have plenty of time to ask questions, and I'm sure there's going to be some, is we need to pay attention to protein. And what does that mean? That means stop thinking about it as a number and start thinking about it as amino acids and bioavailability, and considering what other kinds of bioactives there are in foods. It's a complex answer. When you have acute malnutrition, don't be afraid of specializing the diet for limited periods of time to rescue a child who's at very high risk and put them back into a better category. And that risk is not just simply death or survival. We've developed a new method to measure cognition. It's an eye tracking test, in the same way that we're measuring weight or arm circumference is a real-time measure of your body composition, which we've done with these MAM kids, so kids that aren't on death's door. And that's why I threw out the number of 8 IQ points. I mean, their brain is not working as well. And it's restored when you give them a supplementary feeding. And of course, there's a little bit of attention you have to pay to that. And And we're doing trials right now to see if the fatty acid composition affects the recovery on that. So I think that's about all I planned on saying, because I wanted us to have plenty of time to discuss things. But you know, when you're in the U.S., the national sport, baseball, the last player to bat is usually the worst one on the team. So I'm the last one today to give a formal remark.
Thank you, Professor Manary, for that lovely lecture. The topic is open for questions.
Sir, I have a question. You have shown the cassava as a nutrient, but we have experience of cassava in South India, Kerala. It is related to the fibrocalcific pancreatic diabetes. It is related to pancreatic diabetes after taking the cassava.
He is talking about a thing called K diabetes, which was described by a man called G. Varghese, about cassava causing pancreatic calculi and secondary diabetes. Do you have any experience with that? Cassava as a nutrient supplement, as a source of nutrition, there has been, from one part of India, the south of India, there has been a description of a thing called K diabetes or Kerala diabetes, where cassava has been implicated in causing pancreatic calculosis.
My work with cassava was to try to pick out a very vulnerable, most vulnerable population in Africa and develop something different with them. So we've never been promoting cassava as a food or saying that it's going to be healthy. We were trying to make cassava better. I've lived in the midst of pretty heavily cassava consuming folks. This was part of a Gates Grand Challenge project that focused on the area around Lake Victoria as well as Nigeria. And we didn't see pancreatitis, but we did see occasionally a peripheral neuropathy that was irreversible and devastating if you don't process the cassava, because there's cyanide in the peel of the cassava, which is probably one of the reasons why we kind of chose it in the first place, because insects don't eat it. They're smart enough to not eat it, so that it doesn't rot so easily. But this neuropathy, just to share an anecdote, right? When I first came to Africa in '85, I was working on a hospital on Lake Victoria. About 3 or 4 weeks later, we were called to a village where there had been an outbreak of 125 people who were paralyzed in more or less forms below the waist. And this is from cyanide toxicity, because there was a wedding and they needed to get a lot of nice food for the wedding, and they couldn't use the sort of normal 3-day soak the cassava and dry it and get rid of the cyanide.
Sir, how do you build up the high protein requirement in SAM?
How do you deliver it?
How gradually you increase the protein requirement in severe acute malnutrition?
Right. For sure.
What is the time duration? Because quick building up of the high protein can cause some problem, like nutritional recovery syndrome and other things also.
Yeah.
So how slow or how gradually?
We don't titrate nutrients at all, actually. When I first started, I have to say that I delved into not just the literature and experience of people, and there was all kinds of what I will call today myths about, you have to go easy because these children are so fragile and you're going to disrupt this and that. But the child's appetite is really the brakes that you have to follow. So today we give them access to the high protein food. We know in the first 4 days they're not going to take it, and we're not going to force feed them. They'll take some of it, and they'll accelerate their intake over a period of 2 days, 4 days, 6 days, quite a bit. So I would say provide them with the high protein, high nutrient dense food at the dose you think they're going to need to recover, and let the child's appetite be your guide.
Yes, Sridhar.
This is just a little bit an addition on cassava. Okay, since I'm so close to the microbiota, cassava is full of resistant starch, and that is one of the reasons why we feed, because you want to alter the microbiota. The problem with cassava that we see in the south, the other problem other than pancreatitis, is it's a goitrogen. So there is a way of cooking cassava. We soak it, just like the way you talked about the outer coating. We soak it so that the cyanogens are leached out before it is cooked.
Yeah. Okay. So you.
Thank you for a very, it's in the trenches, as they say. What I wanted to comment on is, and maybe some of the people in pediatrics may not, but India actually has got a very strong tradition where foods were tested. I'm talking about the work done by Tara Gopal Das, where they looked at different traditional foods. How do you combine them to optimize sort of protein quality and also making it a sustainable approach. So my question is, I completely agree with you, we can't just focus on grams per protein or even the protein quality. How does one get information on the digestibility out? Because that is so variable on how the food is processed. And as we've moved into, I guess, less control of food processing. So as someone who's worked in foods and nutrition, we know fermentation increases bioavailability. We know soaking increases bioavailability. So the same food, the protein quality or the protein availability varies on how it's processed versus kind of you have the mom is happy if you give her a package and she can feed it to the kid.
Yeah. Well, I think if you're referring to these protein scoring systems, the digestibility component is in this most modern or the most recent score, the DIAS score, is foods are supposed to be tested as whole foods in a pig model, and they get a number of digestibility, and they're measuring the digestibility at the point where the ileum and the cecum are meat. So rather than something in the feces when the microbes have had a chance to eat up everything. So I think that those kinds of reference values are available for a variety of foods, and in places, like in Europe and North America, foods might be required to have this test before they get licensed by the food and drug kind of people. But I think getting, if you're working in an environment where there are 5 or so traditional local foods that are very frequently used and we don't know information about this, I would say, work with somebody. You send the foods to me or something. I can probably find someone who can do that, give you that number, because 60 is different than 80, and that would be a difference of a third more or something like that.
So we were also told in the previous lecture that if you take the vitamin A content of a papaya in America and vitamin A content of a papaya in India, the difference is gross, almost a value of 500. So even this maize and sorghum, I think the combination of your maize, sorghum, and a tryptophan-based diet is basically because maize and sorghum are deficient in lysine, tryptophan, methionine. Some of them are deficient. That's why we have these food additions which compensate for the amino acid deficits. Is it the same? And how do you know that the maize and sorghum that is grown there is of a high biological value compared to the rest? Because they are the ones that grow very easily in semi-arid areas also.
I mean, how I know is I usually do tests, because that I don't believe that
Or one more question.
But I was going to respond to something else that you said, and with some data.
The lysine, tryptophan, and methionine concentration, that's why we combine?
I mean, I would do tests to look at the bioavailability of that, but I was going to respond. Okay, so we did a trial not too long ago, a couple years ago, with a ready-to-use therapeutic food treating SAM in Ghana. And in order to make it less costly and therefore potentially more accessible, we substituted out some of the peanut for sorghum and soy, okay? And this met everybody's specifications for, for all the nutrient contents and actually had a very equivalent DIAS score. And yet the sorghum and soy, RUTF, was caused, because it was a randomized blinded prospective trial, caused 12% less recovery. So my conclusion about that is that soy and sorghum have something that's not about the protein quality that can be deleterious or detrimental in this case. And could it be isoflavones? To me, but I don't know that for sure, but I do know for sure that soy and sorghum may not be the two things you want to build your
Also increasing
therapeutic diet on.
also increasing the protein load. Do you predispose to acidosis? A low-grade acidosis which could affect bone growth, which could lead to kidney stones, a little bit the way we are taught in theory. Is it a possibility?
Well, anything we can't see might be possible, but I don't think we see.
You mentioned the
see
more
this
the
as
better.
Evidence.
The more the better.
Yes, because even for severe kids, on average, we're talking about 6 weeks or 8 weeks. We're not exposing people to this diet for long periods of time.
And we were scared of the refeeding syndrome. You suddenly increase.
No. We did a trial back on that 25 years ago, and it isn't. These children are already starting in many times with deathly low serum phosphorus levels, and what's happening in the refeeding syndrome is as you heal those cell membranes, the anions and cations that normally want to stay inside cells get kept in there better, and you drop the phosphorus. But it's happening. It's not about. If you take the numbers, okay. What's the difference between 8 and 47? Well, it's probably sixfold. You're subjecting the child to a sixfold higher risk of sepsis and translocation, to mete out your amino acids little by little by little. No, yeah.
Professor Kim, please.
Yes, Mark, you mentioned the study by Steve Collins with crystallized amino acids. Do you think, are there any further studies going that way, or is that I ask because when we have discussed, we made a model of malnourished pigs, and we talked to pig feed people, and they said, why don't you add just some amino acids? Because for feed quality, they are very cheap, and it's good economy to add it to pig feed. So do you think there's a future on that?
Well, I don't know of any studies that are in progress. It's not something that I feel very interested in testing. So, I think that it's, if we think about the circle of our knowledge in terms of nutrition, and then we color that circle, how much of it is really do we know? Excuse me. The whole area of what could be known and what we know. And I mean, it's like a light in a corner of a dark room. And so I honestly, Kim, don't feel like we're ready to engineer foods by putting the components together without carefully then looking for problems. I mean, who would think that soy and sorghum taking out some peanut would result in 12% less recovery? I wouldn't think that. I wouldn't have tried it if I thought it.
Any other further questions, comments?
Sir, Have you got experience of treating anorexia nervosa of adolescents and bulimia?
I don't.
Because they are also acute malnutrition, which is self-induced, not like this epidemic form of
Right.
poverty. So they are very difficult to treat, and they have got mortality of 5% only.
Yeah, they are. And I don't personally, but I wouldn't, I would definitely think of them in the same category as the same principles. As, you know, they would benefit from a therapeutic food when they're in such a bad strait. And like I say, I don't work with them, but I've heard that they're basically impossible to get compliance out of.
Anybody else?
There's one
Yeah.
here.
Well, compared to the severe acute malnutrition children, moderately acute malnourished children are more in number.
Yes.
And there are no definite guidelines for the management and treatment of moderately acute malnourished children. And for severely acute malnourished children, there are guidelines by WHO to start with such a low protein and then build up over a period of time, not rapidly. Is there any guidelines for that, for this moderately acute malnourished children to start with this much of protein and then go ahead to the maximum protein, what you have mentioned, 4.5 grams per kilo per day?
Right. So what WHO says now about severe acute malnutrition is obviously if the child can't eat, has problems with their vital signs, then yes, you should be careful and prudent about dumping a bunch of food in them. But those are really a fair minority of the cases. But they encourage home-based therapy right from the start, at a high level of protein. In terms of moderate acute malnutrition or those kinds of guidelines, I think it's so much more common and there's so much more diversity in context that regional or national or sub-regional guidelines might be in order rather than something from Geneva.
Just to share an experience from our side is that people from here, beside you, sir.
Oh, I'm sorry. It's bright, I mean.
Okay, there are people from my state. We have had a thing called a nutritional rehabilitation center in Davangere, which has been functioning for decades, where the parents are put into a fairly large kind of community hall and taught how to cook food. It is the quality of the cooking and the retention of nutrients, essential nutrients, by preventing overcooking or preventing loss in the water and so forth. It's been functioning for I think about 3.5, 4 decades, more than that, 4 decades now. So that concept in India is pretty old, that you use home available food and modification of what is already available rather than giving supplementation.
Yeah, certainly it's a problem that's so widespread. You need to try to find your solutions locally.
There's
All
nothing
right.
else, then
We're done.
thank you, Dr. Manary. Thank you very much for this lovely talk.